Alright, so we are now at analysis of variance. So in analysis of variance, we will tackle the so-called one-way ANOVA. ANOVA meaning analysis of variance. So we have a definition here of a one-way analysis of variance. So it is a hypothesis testing technique that is used to compare the means of 3 or more populations. So to perform a one-way ANOVA test, so these conditions must be met. So number 1, each of the K samples where K be greater than or equal to 3 must be randomly selected from a normal or approximately normal population. Number 2, the samples must be independent of each other. Number 3, each population must have the same variance. If these conditions are met, then the sampling distribution for the test is approximated by the F distribution. So the test statistic is described by this formula. Okay, so let's have this example. So a medical researcher wants to determine whether there is a difference in the mean length of time it takes 3 types of pain relievers to provide relief from headache pain. Several headache sufferers are randomly selected and given one of the 3 medications. Each headache sufferer records the time in minutes it takes the medication to begin working. The results are shown in the table. At alpha equal to 0.01, can you conclude that at least one mean time is different from the others? Assume that each population of relief times is normally distributed and that the population variances are equal. Alright, so let us now answer the given problem. So first of all, let us find the claim in the problem. So in the problem, the claim was there is a difference in the mean length of time it takes 3 types of pain relievers to provide relief from headache pain. So let us write it here. So we may say at least one of the means is different from the others. In ANOVA, usually our HO is kind of a statement. There is no difference in the means, or there is no difference among the means. And in HA, usually at least one of the mean is different from the others. So for this problem, our claim will be put in HA. So let us copy that, paste it here. So for our HO, there is no difference among the means. Now, for the level of significance, we have 0.01. The statistical test, we have F-test. For the p-value, we will use SPSS. Now, to do the coding in SPSS, So let us first go to variable view and assign a variable named group. So we will put 0 on the decimals, and for the label, let's say medication. Now let's have this values column, so we click that. Let's have a value 1, and then for the label, let's type medication 1, and then you click add. Now we repeat the procedure for the second group. So we have 2 medication 2, and then 3 for medication 3. So we click OK, and then after that, for the second row, we type obs. Obs meaning observations. So we put 0 on the decimals, and let's go back to data view. So for the encoding, we may type for the group column 4 ones, 5 twos, and 4 threes. And then after that, we will type the observations in each group. And then after that, we may now go to analyze, compare means, and then one-way ANOVA. So we click that. For the dependent list box, we drag our observations, so obs, and then for the factor box, we drag the group or medication, and then after that, we click OK. So here's the result for the ANOVA test in SPSS. So we will focus on the p-value. So as we can see, the p-value was 0.269. Now, this value is greater than the designated level of significance, which is 0.01. So it means we need to fail to reject HO. That means there is no significant difference in the mean length of time it takes 3 types of pain relievers to provide relief from headache pain. So let us complete our hypothesis testing steps. So the p-value was 0.269. The decision was fail to reject HO. And for the conclusion, So we may say that there is a sufficient evidence to reject the claim.